We're continuing this problem from the previous video. We are finding the point xy on the circle x squared plus y squared equals 4 that is closest to the point on the plane 3, 1. And in the previous video we found the critical number x equals 3 times the square root of 10 over 5. It's a critical number of the distance squared. Okay, but being a critical number of the distance squared, that is the same as being a critical number of the original distance d. We're doing that for convenience purposes, working with d squared instead of d. Then for y, well, we have that condition on y, the circle equation, x squared plus y squared equals 4. We solved for y and got the square root of 4 minus x squared. We're going to use that when x is equal to our critical number 3 times the square root of 10 over 5. And that gives us y equals the square root of, well, when we simplify it, we get the square root of 10 over 5. Okay, so we have an x, we have a y. Now we only are asked to find the minimum for this problem because we want to minimize the distance. So we're going to use an absolute min-max on a closed interval test. In other words, we're going to use note 70. So this might be a good time to pause the video and review note 70 before we apply it. That applies on a closed interval. So we're going to have to decide what the endpoints of our interval are going to be. Well, think back. This function, d squared of x equals negative 6x minus 2 times parenthesis 4 minus x squared to the 1/2 plus 14. That function is continuous on the domain from negative 2 to 2. Just look at the function. You can see that. It would we'd have a problem with the square root if we were outside of that domain. So that means that x equals 3 times the square root of 10 over 5 is indeed going to be a critical number on this domain. It lives in that domain. And so we're able now, according to note 70, take the d squared evaluated at the endpoints, and those two endpoints are 2 and negative 2. The first one, d squared of 2, gives us the y partner 2, while d squared of the other endpoint, negative 2, gives us the y partner 26. Now, according to note 70, we evaluate the function d squared of x for the critical numbers. We only have one, 3 times the square root of 10 over 5. Evaluate that in the d squared equation, and we get a mess which simplifies to approximately 1.35. Okay, now that 1.35 is the smallest value we got evaluating the function at the endpoints and the critical number. So that will be used for our absolute minimum using note 70. Okay, conclude step 5. Thus the ordered pair xy that's closest to the point 3, 1 is the x coordinate is 3 square root of 10 over 5 and the y coordinate is 3 square root of 10 over 5.